All right, so for this one, we're gonna make a line of fit. It's not gonna be like accurate. I'll show you how to make an accurate one on Desmos. Yeah. So here it says a table shows the length of a bone and the height of people. So the bone length is x. Okay, that's going to be in centimeters. So 33, 25, etc., etc., etc. The height in centimeters again is going to be our y. That's 166, 142, etc., 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 etc. Now the first question, does the data show a linear relationship? So the first thing we want to do is we want to make a scatter plot. So let's make a scatter plot. And what that means is we're just going to be graphing. Now for this one, it's good to note like what's your smallest and what's your biggest x and y. So for x, our smallest x is 22 and our biggest y is 33. All right, so that's an 11. I don't want to make 11 markings, so we're going to go by 2. Okay, we're going to scale it by 2 and we're going to skip to 22. I'll show you how to do that. And our height, our smallest one is 130 looks like, and our biggest one is 166. So that's not too bad, about 36. Maybe we'll go by 50s. I mean by 10s. All right, and we'll skip to 130 again. All right, so let's get started. Let's make our graph. Save some space. Estimate about. I need to go to at least 170. So from 130, so I'm going to have about 5 markings. 1, 2, 5. All right, and then I'm going to do this little jagged part. That means it skips. Okay, oops. Sorry for the blurriness. That means it skips. And do my x-axis. Same thing. And okay, so first one is not 1, it's going to be 130. That's our smallest. Oops. Yeah, that's right, 130. This is our y. And then we're going to go by 10s here. So 140, 150, 160, and 170. Now you can go by 1s, but then you're going to take up a lot of space. You can go by anything else, right? But I'm just going by 10s. And this is the height in centimeters. And for our x, this is going to be our bone length. And it's also in centimeters. And like I said before, smallest one is 22. Let's start there, 22. And we'll go by 2s. 22, 24, 26, 28, 30, 32. And we need to go to at least 33, so that means let's go to 34. Boop, make it a little bit longer. It's not evenly spaced, so I'll change that. There we go, that's better. Okay. Now let's plot our points. So first one is 33, 166. Go to 33, 166. It's a little bit over half. And then we have 25, comma 142. So go to 25 and between 24 and 26 up to 142, just a little bit above. That's nice. Right there. And 22, 130. So 22, 130. That one was easy. And then we have 30, comma 154. So go to 30, up to 154, a little bit less than half. And 28, 152, 28, 152. And also those are really close to each other, or close on the, sure, similar Y's. 32, 159. That one is going to be close to the 160, but not quite. And 26, 141. Right above 140. And then 27, 145. 27, 145. That's going to be in the middle. Done. That's that. Okay, so that's our scatter plot. And now we need to see, does it look like a linear relation? Yeah. They all seem to be going up, all right? So it's not going to be perfectly straight. If you connect all the points, it's going to be some jagged line. So what we're going to do now is, here it is, yes. It looks like a linear relation. All right, we're going to write an equation for the line of fit. So what we would need to do is we need to draw a line of fit first. Now, I recommend a clear ruler or a clear straight edge, because you want to try to get a similar amount of points above the line as you have below the line, or you want to incorporate the distance. Okay, so just even out the distances away from the line. That looks good. All right, and this is why I said it's not going to be exact. All right, oops. I'll show you in Desmos later. That'll look like, yeah, we have 3 on top, and we have 1, 2, 3, 4, 5 on the bottom, right? But the distances, you can estimate it's pretty much similar if you add them all up together. All right, because the ones on top are a little bit farther than the ones that are on the bottom. Okay, so that line looks good. Now we're going to just find good points on the line. Now don't worry, sometimes the line of fit is going to match with the points that are from the table, but a lot of times it's not. Okay, so in those cases, yeah, we just have to find some good points. So this one looks like I'm going to estimate about, what do you guys think? 148. You can estimate maybe this one is 24, 138. Looks good. And this one actually looks pretty close right here. Maybe that one is on the line, right? What was that? 30, 154. Yeah, so sometimes you are going to get a point that is on the line, and sometimes you're not. All right, luckily we did get one. So what we want to do is we want to make an equation. So for our equation, we need y equals mx plus b, and that means we need our b, our y-intercept. Our y-intercept, we're going to find that after we find our m, our slope. So for our slope, we need 2 points. And we chose 24, 138, and 30, 154. Now, if you remember this from the last video, feel free to fast forward. All right, so here we have x1, y1, x2, and y2, because it's the x and the y of the first point, and the x and the y of the second point. All right, so our slope is easy and fun. It's just rise over 1, which is y2 minus y1 over x2 minus x1. And our y2 is 154. Oops, why did I put that comma? Minus 138. over x2 is 30 minus x1 is 24. And 154 minus 138, that's going to give us about 16 over, and then 30 minus 24, hey, not bad, 6. So our slope is, we can simplify that by 2, and we get 8 over 3. 8/3, not bad. And we know it's positive because it goes up from left to right. All right, now we're going to find our b. Okay, so remember our slope is 8/3. So we're going to plug that into our... Here, let me show you another way to find the b. So I showed you the point and slope form the other way. Let me show you another way here. Y equals mx plus b. So we're going to choose one of these points. I'm going to choose 24 and 138. Those are good. So 24 is going to be our x, 138 is our y. So instead of y equals mx plus b, I'm going to substitute 138 for y. And again, if you want to use point slope form, you can. You'll get the same answer. Our m was 8/3. And our x is 24 plus b. All right, ooh, works out nicely. So 8/3 times 24, that's going to give us the 3, cancels out with the 24, so 24 divided by 3 is going to give us 8. Ooh, 64. Plus b. Oh, sorry, 8 times 8 is 64. And we're going to subtract 64 from both sides. And we get b equals 8 minus 4 is 4. And 13 minus 6 is going to give us 7. And there you go. Our equation is y equals, our m is 8/3 x plus 74. All right, what's that? Oh, there you go. That's the equation. That's what they wanted. Now for b, it says estimate the height of a person with a bone length of 40 centimeters. Okay, so for b, remember our bone is the x. It's the x. So we're going to let x equal 40 centimeters. Okay, so we're just going to do y equals 8/3 times 40, and this one's going to be a decimal. I can sense it. It's okay. Oh, I don't know why I put centimeters. Oh well. So here we get y equals, and then 3, we can't simplify 40 with 3, so it's going to be 8 times 40. It's going to be 320 over 3 plus 74. Sorry for that noise outside. And yeah, let's use our calculator. All right. 320 divided by 3 is 106.7 plus 74. So 180.7. We're going to round to the nearest tenth. So let's make our squiggly approximate line. So 180.7 centimeters. Ta-da! And that is it.